Hi, welcome to our presentation. We're Group 9 and our product is called CycloSense. My name is Alejandro.
My name's Omar.
And my name's Jovanis.
In this presentation, we'll go over our project overview, our design and some choices that we're making, the market research we did, and other useful information we've found along the way. So to summarize, we're creating a low-power route tracking bike computer with a robust user interface, predictive maintenance features, and energy harvesting. Our design can be split up into three main sections, first of which is the GPS and the user interface. We're going to be using a GPS module and open source maps to display the rider's position with respect to the roads and bike trails around them. You'll also be able to enter a destination on an app and have directions visible on the display.
Our second system is our sensing stack, which includes a speed sensor. This uses a magnet on one of the bicycle spokes in conjunction with a Hall sensor on the fork, which uses both the number of rotations and the circumference of the wheel to calculate distance and speed. And then we are integrating predictive maintenance, which will look like a microphone near the brakes that uses a predictive ML model to inform the user when there may be abnormalities in the recorded sound.
And our final system is our power and energy harvesting system. This will utilize a bike dynamo as an electric generator to generate power that will be stored in a rechargeable battery. And we will use power ICs in order to convert the voltage to the required DC voltage for the battery and for the rest of the components.
So to summarize our progress thus far, we've defined our project quite thoroughly at this point, and the initial ideation phase has been completed. So now our main focus is to just create breadboarded prototypes for each of the systems that we just went through. And so that'll include getting all of our basic sensors to work, including the GPS, our display, and our energy harvesting stack. And then we are also going to choose a microcontroller to actually run all of this off of for our final iteration. And as far as component selection goes, we've just purchased breakout boards to make breadboarding easier, and obviously we will reassess our part selection as the quarter progresses.
So for our market research, for specifically bicycles, the global market value is $84.25 billion, and by 2033, this is estimated to more than double in global market value. The number of people that the number of cyclers in the U.S. is around 51 million, which is a very large market size, and people are quickly switching over to e-bikes, with a 21.3% of bike users switching over. Our target market that we're going to aim for is going to be recreational bikers.
As far as our competitors go, some major brands are Wahoo, Garmin, and Coros. Each of them have some different pretty nice features. The Garmin and Coros in particular include solar charging capabilities as well. And our product isn't looking to outdo any of these products in any particular area, but we are focusing on minimizing costs and really honing in on that low power angle.
Lastly, we also conducted 2 interviews, one of which was with a more casual biker who enjoys commuting on their bike but doesn't necessarily track their rides or do their own bike maintenance, and the second of which enjoys commuting but likes to go a little bit faster, go on more distance rides, track their rides, and they also do their own bike maintenance. And throughout some of the questions we asked, we learned that both of them would like to see some sort of predictive maintenance or just alerts that they need to perform maintenance on their bike. Other features that they would have been interested in are things like music control or having a GoPro dash cam integrated into the bike. The metrics that they would like to see on a bike computer are consistent with what a lot of the commercial bike computers already display, such as speed, average speed, a live route display, and time metrics. And then we also asked them, when receiving directions, how important the efficiency of the ride is compared to the comfortability, such as going on safer roads and bike paths and less hills, but maybe taking a longer way to get there. And both of them seem to say that efficiency is more important, at least as long as it is not severely dangerous. And lastly, we asked how important it would be to be able to not worry about charging their bike computer, and both of them were interested in the idea of not needing to worry about that, as they feel like they would forget about it, and it would just be one thing less that they have to be reminded of.
So what we've learned so far in this very early stage of design is we've learned a lot about electric generation. We've learned both how they're used commercially, but also sort of how they work internally. And we also learned a lot about what data GPSs give, that they don't just give longitude and latitude, they also give time, number of satellites used, and like altitude above sea level. So this can give us a lot of opportunities to explore different types of data or different abilities for our design. And so far we have two sort of main challenges. Okay, the first problem, is that we want the capability to provide navigation without depending on the internet, so that we could store like a map on the device and be able to clearly show the user where to go. But we're asking questions on like, how are we going to get that map without the internet? Are we going to have a lot of onboard storage? When are we going to get it? And then the second problem is we want an ML model for predictive maintenance on the brakes. So should we do like on-chip design, or should we sort of offload that to sort of the back end? And so that's sort of what we're currently looking into. And thank you for listening.